Hey guys, welcome back to another video. So today we're going to talk about operator overloading, another concept in the object-oriented programming paradigm. So what object-oriented programming provides us is another key feature, which is operator overloading. So what is operator overloading anyways? In C++, we can change the way operators work for user-defined types, like objects and structures. So we know that there are one that is called built-in data types, and the others which are user-defined data types, what we could create. So user-defined data types are not allowed to be added or subtracted. We can't do these kind of objects stuff as compared to those primitive data types that were ints and others that were built in the C++ language. So operator overloading gives us this cool feature that allows us to add, to subtract, to multiply, to any kind of manipulation done for those kind of objects. So what happens here is that there's this operator, which this is two objects. So for instance, you have a C1 and you have a C2. Pretend these are just objects and you want to add them. The compiler will just throw an error and it will not understand because the plus doesn't work for user-defined data types. So instead of doing that, we do some kind of process which is called operator overloading, which you're going to see in the example program, and you're going to see that the compiler will understand it and do something like this, and we'll put it in the result. Here I wrote my boilerplate code, which is necessary for all C++ programs to run. So after writing this code, now what I'm going to do is create a scenario. So suppose we have a class and the class name is complex, and the complex will have a private section and a public section. So in the private section, it will have an integer real and it will have integer imaginary. So in mathematical domains, there's always a complex type, and in the complex type there will be a real part and imaginary part. So we're supposing something like that, and in the public section I'm going to create a constructor. So what I'm going to do is I'm going to put the class name, I'm going to put an input parameter, and also I'm going to put two input parameters. So inside of one is going to be temporary underscore real, and we're going to have another integer which is going to be temporary underscore imaginary. So inside there's going to be a body, and what's going to happen is that the temporary underscore real, whatever is in the input parameter, it will be assigned to the real which is in the private section. And the same thing goes here for the other type, which is imaginary. So imaginary will have the temporary underscore imaginary, which is situated in the input parameter. Okay, so after this constructor is constructed, we're going to have, this is basically known as a parameterized constructor, and CTOR as short. After completing the parameterized constructor, we are going to create a function. So it's called a method, and we're going to be naming the method as something over here, which is, I'm going to be giving it a data type which is void, and it will be called a display method, and it's not going to have any input, and what it's going to do is going to console output the real part, and then it's going to have the plus sign, and then it's going to have the imaginary part, and also it's going to have the iota symbol. So remember, in complex types in mathematics, we used to have a number, like suppose we have a 3, and we used to have plus sign, and then we used to have a 4 iota, something like represented with an iota symbol, but we can't do that, so I'm writing I. So this was a complex type. We're going to discuss about the operator overloading phenomenon here. So what we're going to do here is basically first think of so in order to solidify the concept of operator overloading, we're going to take a look at the primitive data types, like int A is equal to 10, and we're going to suppose int B is equal to 20. So we know that in C, if we do something like A plus B, and when we console output C, what we're going to get is 10 plus 20, which is equal to 30. So when I execute and compile and run this code, 30 as my output. So that was when we're dealing with built-in functions, built-in ints, and built-in data methods and whatever. So that's when the compiler knows when to operate. But suppose here in this scenario, when we created a class called complex, is the compiler going to know? That's the main question here. So for instance, if I have a complex class over here and I create an object, so I say object 1. Now object 1 will have some kind of value. So I like input 7 as the real and 3 as the imaginary. So the same thing, I'm going to create another object 2, and it will have another like random value. So I'll say 2, and it'll have, let's say, 5. So, and we're going to have another object. So basically, we're going to have another one. And in this time, we're not going to give any input parameters, and we're just going to call this as object 3. So here we have to create one more constructor, and that's called the default constructor. So I'm just going to copy this parameterized constructor, and I'm going to paste it over here, and I'm just going to modify a bit by not giving it any kind of input, because a default constructor is defined by having no input parameters. So we'll just call this as a default constructor. So the default constructor has no input parameters, and it will be assigning the real and imaginary parts, which is the private members, as 0. So it's going to assign that as 0. So what's going to happen here is that the object 1 has 7 as a real part and 3 as an imaginary part. Object 2 has a 2 as a real part, 5 as an imaginary part. When object 1 is added with object 2, for instance, if I want to add object 1 and object 2 together to the residual object 3, we're going to do something like object 3 is equal to object 1 plus object 2. So how am I going to know how to do this? Does the compiler interpret this correctly? We'll check out by giving the execute compiler and run button. So the compiler here breaks out and it says no match for operator plus. So operand types are complex and complex. So basically these are operands, object 1 and object 2. These are complex types which we are user defined. And the plus symbol is not understanding these two operands. So this is the operator, and it can't understand. For this kind of scenario, we would need the operator overloading phenomenon. So what we're going to do is we're going to create an operator overloading function here inside of the class. So this is the class basically, and inside the body of the class, I'm going to go somewhere and I'm going to be calling this as the operator overloading. So the basic syntax for this is first the class name, so which is the complex. I'm going to zoom this in a bit so that you can see it properly. So the class complex, the keyword operator, the type of the operator, is it a plus sign, is it an asterisk symbol, or is it a minus sign? So in this case we have a plus sign. So then we're going to have these input brackets. So what are these brackets for? These parentheses, this will have our input. So like all functions do have input parameters. In this scenario, I'll input a complex type, which is C. So this is something what I'm going to explain later on. So hold on a bit. So what we're going to do is we're going to create another complex class object inside of the function, and this is basically called the operator overloading. So I'll just say operator overloading syntax. So this is the syntax for it, and we're going to create an operator temp. So what's temp going to do is temp will also have a real part, and what it's going to do is going to have a real over here, and it's going to add it with the C, which is the input parameter here, and also that. So basically it's going to input the C over here and there as well. So obviously the temp will have an imaginary part as well. So temp imaginary, and it will have the imaginary, which is inside the class, plus C dot imaginary. So now it's going to return the temp. And this is basically a temporary object which was created inside the object overloading syntax or the function. So what this did basically here is that complex C was something which is object 2. So object 1 in this case will be this real function. So it's already inside. So object 1 doesn't have any problem. C.real will be the object 2. So whatever is happening inside the input parameter, that will be object 2. So that will be object 2. And object 1 is this real and imaginary, which are implicitly inside the class. So what happens here is that we create a temporary class, a temporary object, and what it does, it assigns it adds them and holds the value in the real part, and then it will go in the imaginary section. It will add and hold the imaginary sum in the imaginary section, and then what happens is that it returns the values. These values will be returned, and the operator will understand by, in this case, what's happening basically is that object 1 is having a function which is called add, and what's going to happen is the compiler is understanding that object 2 is going to be passed into that function, and then object 1 will be calling a function add and passing in the object2 as an input parameter, which will result in object3 as the result. So this is how this operator overloading will be sorted out. So you can see how intuitive and how easy and flexible this piece of code is as compared to this. This is how compiler will read it, and this is how we humans could write. So it's more easier and user friendly to us. So we're gonna save this code. First, we're gonna check by, I'm gonna / and comment this out, and we're gonna run this code. So basically what we're gonna do is execute, compile, and run this piece of code. And you can see that there's gonna be no errors and nothing in the output terminal. So because we didn't use the function right. So the final steps to show is that the context of object3. Object3 will consist of a real part and will have an imaginary part. So over here we could see that real part of object1 is 7 and real part of object2 is 2. So what happens is that 7 plus 2 is equal to 9. And over here 3 plus 5 is equal to 8. So we're going to have something as an output. So what I'm going to do is object3 dot display function, and what display is going to give us is going to add the real parts of both, and it's going to give 9 plus 8 iota. So hopefully we're going to have 9 plus 8 iota as our output. When we execute, compile, and run this code, you're going to see 9 plus 8 iota in the terminals window. So that was it with the video. We will see you in the next one.